but we will have a quiz over each section. And then we'll be ready for our test. All right, so here we go. First thing I would suggest you do is change the f of x into a y. Now you remember that, right? You remember that f of x is the same as y. It's going to be easier to have a y. All right, so that's step one. Step two, switch the variables. So instead of y equals 2x plus 1, we're going to have x equals 2y plus 1. And then do whatever you need to do to get y by itself. So if I'm going to get y by itself, what am I going to need to do? Subtract 1. So I'll subtract 1. And then if I want y by itself, I will have 2 divided by 2. And there is the inverse. Now, normally we express it as the inverse. So remember how the first thing we did was change the f of x into y? The last thing we're going to do is change the y into the inverse. So this would be the final answer. So this is your inverse notation. That's like a little -1. This is called f inverse. So our job was to find the inverse of this function. So we went through our steps, and this is what we got. Now I want to show you something. Pick a number. 5. If I put 5 into my function, I put in a 5, let x be 5, then y will be what? Right here in the original problem. If x is 5,
10.
no, not 10, 11,
Oh, yeah.
right, in the original problem. Now, I'm going to come down to my answer, and I'm going to put 11, that number right there. I'm going to put 11 into my answer. Well, what happens if I let x be 11? What does that end up being? 5. So notice inverses flip-flop each other. So if 5 gives you 11, then for the inverse, 11 will give you your 5 back again. Every time. All right, let's try the next one. I'm just going to go ahead and write y equals right from the start, okay? All right, who kept track? What is the next step? Flip x and y. So x equals 3y minus 1 over 2. And then what?
Get rid of y.
The y by
itself.
itself.
Yeah.
So the first thing I'd have to do here, if I'm going to get y by itself, first thing I'll do is times by 2. So 2x equals 3y minus 1. And then
Subtract or add
Plus
1.
add the 1. And then divide by 3. So 2x plus 1 over 3 is my inverse. That's my answer. Remember, our job was to find the inverse. All right, we're not going to check them all. We'll check this one more time. Pick a number. 12. Let's pick an odd number for this problem.
3.
3. So if I pick 3, I just don't want to mess with fractions. if I pick 3, if I let x be 3, what does my original problem equal? If I put a 3 in right there, what does it equal? 4? Now, I'm gonna come down here, and I'm gonna put 4 into my x down here. Well, what happens if I put a 4 in there? I get my 3 back again. That's your check. That's your check. That has to happen. So we have a quiz over this. If you want to check your answer, that's what you do. Is there anything special about the number we chose? No, it's random 3. Over here it was 5. Pick whatever you want. Okay? All right, why don't you try C? You and your partner, or you by yourself, I don't care. Try problem C. Did you remember the first step?
Yeah.
You switched your variables? Yeah, that's critical. You gotta remember to do that. You're gonna switch your variables. And then how did you start getting y by itself? Multiply by 9. And then subtract 2. And then divide by 4. So your inverse, and we're gonna get in the habit of writing our inverse notation. This is your answer, is 9x minus 2 over 4. Now we were just starting to get kind of a handle on it, and then we ran into D. D looks a little different, doesn't it? But we're gonna do exactly the same thing. So I'll start by changing to y. So here we go. Here's my problem. And then what will I do next? Switch them. So x equals the square root of y minus 2. Now it looks different, but we're doing the same thing. You have to get y by itself. What do you think we might need to do?
Square.
Square. Absolutely. We got to square both sides because we can't get that y by itself when it's under a radical. So we're going to square both sides. So we have x squared. What happens over here? When you square a radical, what happens? They cancel, and all we have left is y minus 2. And remember, we're getting y by itself.
Add 2.
So we'll add 2. And that will be our inverse. X squared plus 2. So the problem was different, but the steps are exactly the same. Okay. Uh-oh. Now we got a toughie. Well, what do we do first?
The
my
X and Y.
variables, right? So x equals 2y plus 1 over 3y minus 4. Every x becomes a y, every y becomes an x. Switch them all. So since there were two x's, now I got two y's. Kind of hard. What do you think might be an option for me? What can you think of? Something to do?
Multiply by 3y plus 4.
Exactly. We're gonna multiply, not by 3y, we're gonna multiply both sides by this denominator. 3y minus 4. Because what's gonna happen if I multiply by that, won't those cancel?
Yeah.
So basically what I'm doing is bringing this denominator over to the other side. Alright, so let's see what I've got now. I've got 3yx minus 4x equal to 2y plus 1. So this is gone, I brought it over here. I distributed, and now I'm here. This is where I am.
Minus one.
What?
You start canceling it or taking them over to minus one?
So minus 1 and then divide by 2. Alright, let's talk about that. Because it makes completely good sense. He says we're gonna subtract 1. And then we're gonna divide by 2. Now, is y by itself over here?
Yeah, but there's a Y.
But there's a y on the other side. Bummer. So that is not what we want to do. It makes sense, but we can't. So here's what we're gonna do. We're gonna put all the y's on the same side and all the non-y's on the other side. So basically what it means, I'm gonna switch these two. Because if I bring him over here, I'll have my y's together. And if I bring him over here, I'll have my non-y's together. So I'm just gonna switch these two numbers. So I have 3yx minus 2y equals 4x plus 1. So take a look at that, make sure you followed what I just did. My goal is to solve for y. But there's two y's. So I gotta get them on the same side. So flip flop these two numbers. Now, I'm gonna factor out the y. So there's a y there and a y there, so I'm gonna factor it out. And I'm left with 3x minus 2. See that? Now, remember a minute ago we had two y's? And that was bad. How many y's do I have now? 1. And that is good. So now I'm going to divide. And my inverse is 4x plus 1 over 3x minus 2. I know that's a little bit hard. You'll get good at it though, 'cause you're gonna practice. You'll get good at it. Alright, let's see if you can remember the steps to do the next one. I erased part of it, but some of it's still up there. Step 1. I see some of you busily writing, awesome. What's step 1?
Switch your x and y.
Yeah, so x equals y minus 2 over 4y plus 1. Multiply this guy over to this side. So we'll have x, 4y plus 1, equal 8y minus 2. Now remember, when you do that, guys, you're literally bringing this over to this side, so he's not there anymore. All you have is the 8y minus 2, because you brought this over here. Now what do you think? Distribute. So 4xy plus x equals 8y minus 2. And then this is the step that a lot of times we forget, but it's a very, very important step. What do we need to do now?
Subtract the 8 over.
We need to switch these guys. Those guys need to switch. It's always gonna be these two that need to switch. So 4xy minus 8y equals negative x minus 2. Remember, when you move it from side to side, you change its sign. So when I moved to this guy, he became a negative x. And when I moved this guy, he became a negative 8y. When you move them from side to side, they change sign. Good, now what?
Distribute a y.
Take out my y. Take out my y, factor out my y. So I'm gonna take out a y. Now, I know what you're thinking. You're thinking, oh wait, Mrs. Ford, can't you also take out a 4? And you can, but don't. Because remember, what is your objective? To get y by itself. So you don't wanna take other stuff out. You just wanna take out the y. So y, 4x minus 8. Took out the y. And then last step, divide. By the parentheses. We'll be having a quiz over that. But I think I'm gonna wait, since I don't see you tomorrow, remember, we'll do it on Monday. And we'll practice on Monday and I take a quiz the next day. Okay? If we have time, at the end of the period, we'll come back and do a couple more for practice. But we got a little bit more we need to do here. So number 2. Is f of x a function? So, this is a 3-part question. Here is your picture. The question is f of x a function? Is that picture a function?
Yeah.
Yes, because it passes the vertical line test, right? So, yes. Passes VLT, vertical line test. Is its inverse a function? Now, we've been finding inverses here. If I found the inverse of that parabola, it would not be a function, and here's how you can tell really easily. We already did the vertical line test. That's to test if the original is a function. I'm gonna do the horizontal line test. What happens when I draw a horizontal line through that figure? It hits here and here. That means the inverse is not a function. To test If the original is a function, use the vertical line test. To test if the inverse is a function, use the horizontal line test. If both of these are yeses, you're what we call 1-to-1. But this doesn't pass both tests. To be 1-to-1, that's the next question there. To be 1-to-1, you have to pass both tests. So you have to pass vertical and you have to pass horizontal. This one does not pass both. All right, let's look at the next picture. Is that sideways V is that a function?
No.
No. It fails the vertical line test. Did everyone agree? Is its inverse a function?
Yeah.
Yes, because it passes the horizontal line test. Is it 1-to-1?
No.
No, because you have to pass
Both.
both. So that's a no. Doesn't pass both tests. All right. One more. Look at that shape. Is it a function? Yep. Passes vertical line test. Is its inverse a function? Yep. Passes horizontal line test. Therefore, is it 1-to-1? Because it passes both tests. And what 1-to-1 means is, if you built all the ordered pairs, like all the points on this thing, none of the x's would repeat and none of the y's would repeat. It's a 1-to-1 relationship. All right, well, that's pretty easy. Let's see what's next. Sketch the inverse. Now, I got some graph paper here for you. I've got a grid on there. You're welcome to use that grid. Sometimes it's easier, like to have actual graph paper. So if you'd rather do it on this, that's fine. If not, that's fine too. But do hang on to this paper because we will be doing some graphing later on another day that you probably want this. If you don't use it today. And I always have graph paper. It's over there next to Adam. On that shelf, so if you need more. Okay? So here's what we're gonna do. This is really, really easy. While I am reproducing this picture up here on the board, here's what I want you to do. I want you to go through and every point, like there's a point right here, I want you to label it. That's 0, 1. So I want you, while I'm drawing this picture, I want you to go through and label every single one of those points in picture A. Alright, so just figure out what the coordinates are. Alright, how do we feel about that? That okay? Now we're gonna sketch the inverse. I want you to think back to our equations. When we had to find the inverse of an equation, first thing I did was change the f of x into a y. And then what? What was the next thing I did after I changed my f of x into a y?
The X and Y.
Flip the x and y. So guess what I'm gonna do? I am gonna flip my x's and my y's. So in other words, I'll just start over here. Instead of plotting -4, 0, I'm gonna plot 0, -4. So that point right there, I flip the x and y and plot the new point. And then this one would be -1, -3. You don't have to label all these if you don't want to. This one would be -1, -2. And this one would be 0, -1. So there's the first part of the picture. Notice that in the original, we had this little trapezoid thing on the x-axis. Now where's that little trapezoid thing? On the y-axis, because I changed my variable. All right. That's going to become 1, 0. That's going to become 0, 1. Two, 2 won't change, will it? 2, 2 stays the same. And then 0, 3. Now you got to connect them in the order they came off of that picture. But do we essentially have the same shape? It's just up and down instead of sideways? So, how do we graph an inverse? Super simple. We just switch the order of pairs. Okay, so you do the next one. You do B. You're graphing a little semicircle. You don't have to label your originals, but I like to do that. So that you get the right spot. I started with a semicircle on top of the x-axis. And it ended up over here. Is that right?
Yeah.
Just go point by point. So plot 0, 2, right here. That's 0, 2. Plot 2, 0. That's right here. Plot 0, -2. Right there. Alright, we have one more topic. Talk about it, and then we'll be done with that, and maybe we'll get our homework done. But, here's the last thing we need to talk about. Number 4. 4 and 5 are related, but they're different kinds of problems. All right, so we want to find x, y for this set of equations that we have. You do not need to stress about this. These are called parametric equations. Parametric equations. And we use parametric equations to describe motion a lot of the time. So basically, somebody's handed me a couple of equations, and they want to know t is like time. It's like 1 second. They want to know, okay, where is this object at 1 second? This is so easy. Do you have any thought on what you might do? Plug it in. Exactly. So if you plug it in, remember you're finding an x and a y. If you plug in 1, what is your x? 3. If you plug in 1, what is your y? Negative 3? Because it's that easy. Okay, it's that easy. Don't let the harder equations freak you out. Number 2, or B, has harder equations, but you're going to do exactly the same thing. This time you're going to plug in 7. So if you plug in 7 up here, what's 7 minus 3? And the square root of 4 is 2. So your x is 2. And 7 squared is, there you go. That's it. That's all there is to it. So the equations can be as wacky as you want. You're just going to plug in whatever number they give you. All right, so that's easy. Number 5. Find a direct algebraic relationship between x and y. Now, does this problem have an x and a y in it?
Yeah.
Yeah. Unfortunately, it also has a t. They're parametric equations, so it has a t. So what you're going to do is get rid of the t. You're going to get rid of the t. Now there are a couple of ways you can do that. Do you remember the process of elimination, substitution and elimination? If I want to get rid of the t's, these are not going to match, they don't match. But if I times this equation by 2 and this equation by 3, would the t's match?
Yeah.
So this equation would be 2x equals 6t plus 2. And this one would be 3y equals negative 6t. And then when I add them, the t's are gone. And what is left? 2x plus 3y, I'm adding, equals, those are gone, and all I have over here is 2. So I started out with 2 equations and 3 variables, and I ended up with 1 equation and 2 variables, x and y, direct algebraic relationship. 1 equation with x and y. Let's look at B. Can you do the same thing with B?
Multiply by negative 7.
if you're going to eliminate the t's, you're gonna have to multiply the top equation by -7. Would everyone agree with that?
Yeah.
Kids, you've done this so many times in your life, elimination. Just take your time, you can do it. So -7x equals -7t minus 28. And then y equals 7t minus 3. Now I know those look different than they looked in first year algebra, but you're gonna do the same thing, you're gonna add them. So these would be -7x plus y, I just add those, equals, these canceled, so equals what? -31. Your job, I know the directions sound so hard, trying to direct algebraic relationship, your job is to get one equation with just x's and y's. Now, on that particular problem, I want to show you another strategy. I always eliminate, I'm an eliminating person, always, but you could substitute. In other words, I could get t by itself by subtracting 4. Does that make sense to you? And then I could take that and plug it in right here. So I would have y equals 7 times x minus 4 minus 3, which is y equals 7x minus 28 minus 3, or 7x minus 31. Now, it looks a little bit different than this one, but aren't those the same equation? Just rearranged. So, I will always eliminate because that is what I like best, but you certainly, if substitution works for you, you can substitute. On that problem, it's okay. I don't like it for problem C because you're gonna have fractions. If you eliminate, you won't have fractions. If you substitute, you will. So take a second, do that last problem, problem C. However you wanna do it, substitution or elimination. You see if you can write one equation and end up with an equation that looks like this. That's your goal. Jordan, what did you decide to do?
Multiply the top by 3 and the bottom by -2.
So she multiplied the top by 3 and the bottom by -2, because that will make the t's cancel out. Now, could she have multiplied this one by -3 and this one by +2? Yeah, you multiply by whatever you need to make them cancel. All right. So now when I add 3x minus 2y, you're adding, can't combine them. 3x minus 2y equals 14. Is that okay with everybody? All right, let's get out our homework and take a look at the 1.5 homework. You guys have been such troopers with my as much as we can get done. we'll get this whole thing done, let's see. Number one. Everybody got it out? 1.5? Alright. Y equals 3x minus 8 over 4. Alright, who remembers how to find the inverse?
Flip them.
Flip them. So x equals 3y minus 8 over 4. Multiply by 4. So multiply by 4. Add the 8. And divide by 3. So what goes in the answer blank? F inverse. That's what this is. This is F inverse. 4x plus 8 over 3. Does anybody have a question about that? You okay? Alright, now the next one's one of the harder ones. So let's see, this is the time we'll have a quiz over next Tuesday probably. So let's see, I got y equals 8x plus 2 over 5x minus 3. Alright, here we go. Flip them. All of them. So all of the x's become y's and all the y's become x's. Good.
Then what do you do, the denominator times the top?
We're gonna bring this guy
Or the x and the.
over here.
Yeah,
So we're gonna have x times 5y minus 3, we're bringing him over, equals 8y plus 2. When you bring him over, he's not here anymore. So it's just 8y plus 2. What? Distribute. So 5xy minus 3x, I'm just distributing, equals 8y plus 2. Big, big, big important step now. Who remembers?
Subtract that 8 y over.
Move these two, right? These two right here need to be moved. Both of them need to be moved. So when you bring the 8y over, he'll become negative. And when you move the 3x over, he'll become positive. So 5xy minus 8y and 3x plus 2. So he comes over here, it becomes a positive 3x. He comes over here, it becomes a negative 8y. You with me? Okay. Now what? What did I do that for? What did I move those things around for? So I could factor out my y. So out comes my y. And I'm only gonna bring out my y no matter what. 5x minus 8. And then what's our very last step?
Divide the 5x.
Divide by my parentheses. So 3x plus 2 over 5x minus 8. And then, just to be like perfect, I'm gonna change that y into an F inverse. We'll practice that on Monday, quiz on Tuesday, probably just like that. All right, sketch the inverse. So we we have this original picture drawn. So, you don't have to do this, but I like to do it. I like to label my original points. Because I know that when I do my inverse, I'm gonna flip them, right? So stay organized, it's really easy, but stay organized. Negative 4, 0 becomes 0, negative 4. Negative 3, negative 1 becomes negative 1, negative 3. 0, negative 2, so there's that little triangle. 2, negative 1, and 0, 0. Make sure that's what your picture looks like. Take your time plotting your points. I know you all know how to plot points, but sometimes you get carried away. X, comma, Y. Good? All right, and then draw a one-to-one function. Now, what does it mean to be one-to-one again? Passes both texts. So draw a shape that passes both horizontal and vertical. So Kyle's back there saying, how about my friend, the identity? Does that pass both? How about the reciprocal? I think that passes both too, doesn't it? So that would be another example. Oh,
What about absolute value?
no. Absolute
Wait, no.
value, absolute value doesn't pass horizontal.
What about cubing?
Cubing, will cubing pass both? It's one-to-one. How about logarithm?
Yeah.
How about exponential? Yeah, those guys are one-to-one also. Square root, yeah, square root.
Obviously.
All right, so if you are here today, I'm gonna go ahead and record that homework is done. Do not turn it in. Do not turn it in. It is due, or it's going to be due on Monday, but you're going to have it done already. So, all right.
concussion.
He has a concussion?
Yeah, I think so.
What happened?
Yeah. He got hit with the punt. When he blocked the punt, it like just nailed his head.
That's what he got.
Yeah, because the punter like dropped
He got
it,
murdered.
and then he just picked it up and like tried to kick it quick, and it went boom.
there's
It was
no shot
bad.
in that
I'll show you the clip next for if you need it. He's messed up.
Oh, poor man.
He did.
The ball like went boom and just
Last
flew
night.
to the sideline.
Last night, during the game.
Not in the game. He thought he was just sick all week because he was like, my head hurts. So then he like failed the concussion test.
Poor kid.